In this example, we're going to use an automatic transmission. So we'll be using this side of the schematic. But the condition is that we have a click when we turn the key to the start position, but the motor does not crank. If you remember from a prior video, when we have a click from the starter solenoid, what it's doing is it's saying that we received voltage down at the S terminal and that it operated. So what that's telling us is that we do not have to test on this side of the schematic or make any tests on these components of the car, because by getting the click, it means that all of these had to function as designed to allow the solenoid to click. Where we need to start our testing is on the motor side of the circuit, which includes the battery cable, the switch that's in the starter solenoid, and the motor itself. So the first thing I would do is come down to the B terminal of the starter and hook up my meter and crank the vehicle and make sure that I'm getting battery voltage down at that location. And in this case, I am getting battery voltage. So now that I have the 12 volts here at the B terminal, what I'm going to do is make my next measurement at the M terminal, because the job of the solenoid is to pull over the switch and also then throw the starter gear into the flywheel, the starter drive gear. When I come down to the M terminal and put my meter there and crank the car, meaning turn it to the start position, what I'm getting now is a reading of only 3 volts down at the M terminal. But when I was up at the B terminal, I had 12 volts. So what does that mean? Does that mean that there's an open in the switch at the solenoid? Think about it. If there was an open in the switch at the solenoid, I would measure 12 volts here and I would measure 0 volts here. But by measuring 3 volts here, it's saying that this switch has pulled over, but there's corrosion somewhere between the B terminal and the M terminal, usually on the contacts of the switch, and that's using up much of the voltage so that the 3 volts that the M terminal is receiving is not enough to allow the starter to crank, and not even enough to make it crank slow. Maybe if we had 6 or 7 or 8 volts, we might have had a condition where the starter tried to crank or moved a little bit and then died out. But with 3 volts, there was not enough there to even make it start to turn. So the repair in this case would be replacing the starter, since nowadays the starter and solenoid are replaced as a unit. Years ago, we would have just replaced the solenoid, and if it was my own car, I would have taken the solenoid apart and tried to clean this switch before I would incur the expense of replacing the starter. But nowadays, we are pretty much stuck with replacing the starter, because in many cases, the starters are made to be not serviceable, and they make it difficult to find the parts that you would need because they're just not readily available. In the next video, we're going to talk about a couple of special situations that can happen that affect what your diagnosis may be. There are some times where you may get a click and you may think that it's a bad starter motor, but there's a few other things you have to check. And there's some other times where you're not getting power to the starter, or the starter's not cranking the way you'd expect, and there's something with the security system. So in the next video, we're going to just discuss these, because while they don't happen as often to create a problem with your diagnosis, they can happen, and if you didn't understand that these were possibilities, they could lead you to a misdiagnosis.